Hello and welcome back. In this section, we'll be looking at questions from the 11 most repeated topics in chemistry UTME. Now, before we go on, I would love that you pause the video, attempt each question before watching the solution to the question. Now, question 1. Calculate the mass of chlorine gas which occupies a volume of 1.12 dm cube at standard temperature and pressure. We have that the atomic mass of chlorine is 35.5 and molar volume of a gas at standard temperature and pressure is 22.4 dm cube. Now, chlorine gas is diatomic. Diatomic, that means that for 1 mole of the chlorine gas, you have it as Cl2, and the volume of 1 mole is 22.4 dm cube. Now remember that the atomic mass for chlorine is 35.5. Being that you have 2 atoms in 1 mole of chlorine gas, you're now going to have 35.5 times 2. So the mass of this gas will be 71 gram, and its volume 22.4 dm cube. Now we're being asked to calculate the mass of chlorine gas which occupies a volume of 1.12 dm cube at standard temperature and pressure. So the mass is unknown and its volume is 1.12 dm cube. So we simply cross multiply. We have that 22.4x is equal to, when you multiply 71 by 1.12 dm cube, you're going to have 79.52. So our x is simply 79.52 divided by 22.4. So x is 3.55 gram, and that gives us option B as the correct answer. I hope that was easy to solve. Okay, next question. 50 cm cube of hydrogen are packed with 20 cm cube of oxygen at 100 degrees Celsius and 1 atm. The total volume of the residual gases is, now this question is in accordance with Gay-Lussac's law of combining volumes. First of all, you're going to have a balanced reaction equation between hydrogen gas and oxygen gas. And our products, we have water. Now look at the ratio of the volumes. For every 2 volumes of hydrogen gas, we have 1 volume of oxygen gas, and then 2 volumes of the product. We're looking at these numbers here. Oxygen is 1, but you don't need to have 1 written, and for the product you have 2. And we are given 20 cm cube of oxygen gas, we have 20 cm cube. So that means if oxygen is 20 cm cube, then hydrogen will be 2 times 20, 40 cm cube. Remember the ratios. Then the product will also be 40 cm cube. But we're given 50 cm cube of hydrogen. That means, looking at the ratio of the volumes, we had hydrogen in excess. So that means not all of the hydrogen will react, just 40 cm cube will react. And we are going to be left with 10 cm cube. How? 50 cm cube of the hydrogen given minus 40 cm cube. Then we have 10 cm cube. We are being asked the total volume of the residual gases. The total volume of the residual gases will simply be the volume of hydrogen that did not react, which is 10 cm cube, plus the volume of the products, 40 cm cube. And we have it as 50 cm cube, option A. I hope that was easy to solve and you enjoyed this. Now let's go over to the next question. By means of filtration, 1 component can be obtained pure from an aqueous mixture of sodium chloride and... Now you have to note that sodium chloride is very soluble in water. So if this is an aqueous mixture of sodium chloride, you see that the sodium chloride, which is a salt, will be very soluble. Now for you to use filtration to obtain a component of a mixture of sodium chloride, then in that mixture you're going to have sand. Why? This is because sand is not going to be soluble when added to this mixture. It is not going to be soluble. You're going to see the sand particles in this mixture. And filtration, being a separation technique, is used to separate an insoluble solute from a solution. And if you watch, you see that sand is insoluble. So if you want to use filtration to separate a component of this mixture, then definitely sand must be a component. Next question. Which one of the following reactions is correct as written? Now, note that a balanced chemical reaction equation is in line with the law of conservation of mass, which states that matter is neither created nor destroyed. That's simply trying to tell you that the mass of your reactants should also be equal to the mass of your product. And with that, we have option C as our correct answer. Now let's look at this option. We have one atom of sodium in the sodium hydroxide, which is in the reactant side. And when you go to the product side, for the salt, you also have one atom of sodium. For oxygen, we have 5 atoms in total in the reactant side. Look at 1 in the sodium hydroxide, and the sulfuric acid, 4 atoms of oxygen. So when you sum, you have 5 atoms in total. Now let's go over to the product side. For the salt, we have 4 atoms of oxygen, and for water, 1 atom. So complete. Hydrogen, we have 3 atoms in total, 1 here in the sodium hydroxide and 2 in the sulfuric acid. Now let's go over to the product side. For the salt, 1 atom of hydrogen, 2 atoms of hydrogen in water, so 3. For sulfur, we have 1 atom in the sulfuric acid, and in the product side, we also have 1 atom in the salt. So that makes option C correct. Now let's look at the other options. Option A, we have ferric chloride, 1 atom of iron in the reactant side and also 1 atom of iron in the product side. Now look at chlorine, 2 atoms in the reactant side but 3 moles in the product side, so this is wrong. For the second option, we have the lead nitrate and the hydrogen sulfide. Now lead, in the lead nitrate, we have 1 atom, and the lead sulfide, we also have 1 atom. Now let's look at the nitrogen. In the lead nitrate, we have 1 atom of nitrogen, and in the nitric acid, we have 2 moles of nitrogen. So this is wrong. For the last option, we have 2 moles of ammonium nitrate. Now go over to the product side. We have nitrogen having 2 atoms. And for water, we have hydrogen having 4 atoms in total. 2 moles of hydrogen times 2 atoms of hydrogen. But look at the reactant side, we have 8 atoms in total, 2 moles times 4 atoms of hydrogen. So you see that this is already incorrect. Okay, next question. Diffusion is slowest in solid particles than in particles of liquid and gases because? This is simply because solid particles have less kinetic energy than the particles of liquids and gases. Now you know that the 3 states of matter, we have solid, liquid and gases. Solid particles are closely packed. They have the least kinetic energy, and this is why solids are rigid. Now liquid particles are not closely packed as solid particles. They are spread apart from each other a bit, and gaseous particles are spread far apart from each other, and that is why they easily diffuse and they have the most kinetic energy. I hope you enjoyed this section. Okay, now if you'd love to have more access to UTME past questions with simplified and detailed video solutions, then you have to get the I-Class Simplified UTME video series, where expert tutors provided detailed video solutions to over 600 UTME past questions for each UTME subject. And the most beautiful thing about this video series is that these video solutions to these questions have been structured topic by topic according to UTME syllabus. Now, if you're interested, you can call or WhatsApp the numbers shown on the screen to get yours.